There's so many tech stacks to choose from. How are you supposed to make the right choice? I didn't. Over the last decade, I've changed stacks so many times. From Rails to Elixir to Go to T3, I've worked with a lot of different tech. While I like the tech that I'm using today, there's a lot of things that were cool about those old stacks. So I decided to go back and try them. All of them. I built the same app 5 times, one for each stack I've used throughout my career. Now I'm going to tell you all about it. But first, we need to talk about sponsors. All these stacks needed to be hosted somewhere, and only 2 of them could be hosted fully on Vercel. I immediately knew who the right host was, so I reached out to them and they were down to sponsor. Man, I'm so happy I did. Fly.io sponsored this video, and they gave me this to say. So that can't be right. There's nothing on here. Huh? Okay. Seriously though, Fly's been incredible to work with. All they asked for was as much feedback as possible. They even asked if I was down to live stream my attempts to deploy on Fly so they could learn from my experience. Anyways, I think it's time to head to the lab. Let's go nerd out. Oh boy. Rails time. This is going to be interesting. Okay, I don't need these glasses that badly, and I'm getting massive reflections. Those are going off now. Not that Rails looks any better with or without glasses. This is an interesting experience, and also the one that delayed the video the most. I used to use Rails way back, like when I was in college, but I admittedly haven't touched it much since. Obviously, I'm biased. I haven't been the biggest fan of Rails for a while, but I went in hopeful, and there were some things that surprised me in a positive way, but even more that surprised me in a less positive way. So let's dive into those one at a time. We have the app deployed here. One thing I'll say positive, it flies. It is faster than I expected by quite a bit, especially because I'm on the free tier on Fly.io right now. And I'm going to sit here and hammer this. I'm clicking as fast as I can, and you can see it comes through pretty quick. Especially when you consider the fact that when we look at the network tab, it's doing 2 requests each time. Because the first request for the vote is a post request. It doesn't return new data. It tells the browser, hey, reload the current page. It gives you the redirect. So as such, we have to do a second request to get the updated page data for every single click. Not great, but it flies. I'm also admittedly very close to the server. I'm in SF. It's in San Jose. All things worth noting. But how is it actually to set up, get started, work in, and deploy? All great questions. I have the project here. The first thing you might note is the sheer number of folders. This isn't like I added a whole bunch. This is relatively fresh. I was blown away at the sheer amount of stuff. It's just so many files. And it's not like you need many of these or they're useful to everyone. It just like creates a whole bunch of stuff for mailers. Like if it was just here, that's one thing. But if we hop into view, sorry, I have to scroll all around. In view, home, fine. Layouts has 2 mailers as well. Just all these things get snuck in. You have jobs as well. JS has its own thing in app. I don't even know if we're using any of this. I think it's just here. Helpers, don't know if any of these are doing anything. They're just here. Yeah. To be fair, a lot of this is expected in MVC frameworks, which if you're not familiar, stands for Model View Controller. If you come from these older ways of building like the Laravel world or the Rails world, it might seem familiar and welcoming. But if you've been spending a lot of time like I have in the modern full stack TypeScript world where we've largely ditched MVC, it's jarring how many things you have to touch to make a change. Especially when you don't have the VS Code extension set up, it is very annoying to hop between things. So like, if I'm in Pokemon RB and we create win percentage, and then we go to the view Pokemon's results, and you make a reasonable mistake, like I made, you put wins here. You can't command click this to go somewhere. Even with the extension, when you command click these guys, it brings you to like random internal things from your gems. So here it brought me to each with index from rack, whatever that is. So you can't actually go there and see if this worked or not. So to see if this worked, I have to run the command locally. I have to go hop in here. That's not the local version. Cool. Go over here, click results, and then see we get an error. To their credit, The error points you to the specific line in the specific file. Not the case with a lot of tools, so I did like that a lot. The experience when you do hit a bug in dev for debugging is not too bad at all. But the fact that you can so easily do these things that feel preventable without having the context here is just annoying. To emphasize the point of how often you're jumping around in Ruby on Rails projects, this pretty stock minimal project has over 1,000 lines of code, but also over 80 files, 48 Ruby files, and 11 ERB template files, on top of the 3 HTML files as well. That's a lot. 83 files to only 1,000 lines of code. There's a lot of these files that have like 5 lines that are template-y, but if you delete them, they might break things. It's annoying to hop around a code base like that, and I found it relatively tedious. I should probably talk more about the actual experience setting this project up, though, because it was both really smooth and really annoying. The official instructions for setup on Mac were quite out of date. They recommended the wrong Postgres version. Thankfully, you can just run SQLite in dev and Postgres in prod, which is what I ended up doing. But man, if you follow the Stack Overflow answers, you're in for an interesting experience because Rails is so prolific and old that most of the answers on Stack Overflow are 10 plus years old and mostly out of date when it comes to modern things. Stuff like, as I just went into that wrong file here, brew on Mac's no longer in /bin. Now it's in /opt for ARM-based Macs. Don't feel like going into the details on that. But a lot of the docs were wrong about these things. Also, I don't even know how this happened. I didn't write down enough details. When I ran the official Rails setup commands, it added things to my .zshrc, like my zish config file, and broke my config entirely. I had to go through and manually clean it up because of all the shit that Rails added to it. Obnoxious. If you're just a Rails dev and you've had this stuff set up for years, I'm sure it's not a big deal, but as someone who has never ran Rails on this computer before, it was obnoxious, especially because the setup times would reach like 6+ minutes sometimes. I don't know if like the source for gems was slow or something, and reruns have been, for the most part, faster. But I had a random reinstall where I was setting up a new project, which we'll talk about in a second, take over 6 minutes after already fetching all the gems. So not a consistent experience, to say the least, especially since we have things like PNPM and Bun in the JS world. Rails doesn't have that level of focus on the performance for the developer experience. I should probably talk about my Tailwind experience quickly because it was rough. If you haven't set up the project yet, you can use --css Tailwind, which will automatically configure things for you. But if you have set up the project already and you follow these instructions, the result will not work and it will be very obnoxious to debug. I say from experience, having spent an hour and a half plus just trying to figure this all out. Thankfully, this guide was created by Nick Agliano that I found after I fixed the problems, and he seems to be a more prolific Rails dev, and even himself says that this was not as smooth as he had hoped for, and he made this very long tutorial on how to do it right. So hopefully that helps emphasize how bad it was. The thing that was missing for me, in case you end up in the same boat, is if we hop over to Layouts, Application, this Tailwind style sheet tag here was missing the data turbo track reload. Once that was added, it behaved. Obnoxious, but at least it works now. So now the whole project's working. What's the actual experience working in it like? Great question. I mentioned before you have to hop around files a lot. If you don't have the VS Code extension installed, it's obnoxious. But once you do, it's pretty nice because you can just command click and it will bring you to different places. So here it says that this vote class, it belongs to winner and loser. I can command click winner or loser and it brings me back to the Pokemon that it's bound to. The fact that Active Record and the VS Code extension can build that relationship is really nice, but also emphasizes how weird it is that the views in the ERB files can't have that same level of integration. Kind of annoying. I've gotten so used to command click on the front end to get back to my backend file from my modern stack stuff that this felt weird and unexpected, but at least it works at this level. That extension, though, comes with a fun quirk. I'm going to uninstall and reinstall it quick so you can see what I'm talking about. By the way, this Ruby extension, it's by Shopify because they're all in on Rails, which I found interesting. What I found more interesting is that when you first set it up, it sets a color theme by default. So if I uninstall and then reinstall this, it immediately sets a different theme in your editor, which is so annoying. You go back and pick the right theme. When I did this first time, it gave you a little warning in the corner that said, hey, by the way, we recommend using our theme because we have a lot of different colors. It's stupid. I hated that so much. I shouldn't, don't take over my editor like that just because I installed something to make my code read proper. Ugh, obnoxious. I really want to showcase this smart ideas, iffy execution experience that I had back and forth with everything. I'm going to do it with Active Record, because Active Record, for the most part, is really good. I would go as far as to say it was the first ever good ORM, which, if you don't like ORMs, blame Active Record. If you do like ORMs, thank Active Record. These guys pioneered a lot, and honestly, there are things in it that I miss when I use other modern tools. One thing I found really nice is the way they handle source of truth. It's pretty common to have a migration folder that has all the SQL migrations that you run into schema that you write separately. The issue here is you can have drift between them. If you have fields that exist in the schema but not the migration, or vice versa, that's not a reliable experience. You cannot do that with Rails because Active Record doesn't let you write a schema. As they say here, the file is auto-generated from the current state of the database. Instead of editing the file, please use the migrations feature of Active Record to incrementally modify your database and then regenerate the schema definition. This is great, because the source of truth for what the schema is comes from running all the migrations. And whatever results after the migrations have run, that is what your schema is. It's weird that they're committed twice like this, but at least you have this one place you can go look and be like, oh, yeah, here's all the fields that exist. And that's not something you can go delete in here and expect it to change. You change it by making new migrations. But here's where the Rails magic gets weird. Here is a real migration command that I ran to add the fields name, dex ID, and sprite. Notice the word Pokemon at the end here. If you're wondering how it knows which model to add things to, it's because I put the word Pokemon at the end here. It uses the name of the migration you generate to determine which things to apply changes to. So the add fields to Pokemon migration is adding to Pokemon because I named it that way. And I learned that because when I tried to run this migration with add mon fields, it created it, but it didn't do anything. It has no idea what to do because the name didn't give it the data that it needs. But if I named that Pokemon, it would have figured it out. Why? There are ways to run these migrations and build them where you specifically flag with command line arguments which model it should touch, but none of the docs show that or recommend that. They all have you use this weird magic thing because it's so elegant. I hated that. And that like pseudo elegance of the weird magic where on one hand, they do something stupid like that auto tags the right model based on what you did and how you named it. But on the other hand, I still have to touch 15 files to show a specific piece of data on a page. That contradiction really rubbed itself in my face throughout my experience trying to work in Rails. It just felt like the wrong things were magical and the wrong things were tedious. But there were cool ideas amongst all of this, and I'm really thankful Rails exists, both because it's been stable forever and things written in it can continue to be maintained and work well. More importantly, because everything else I worked in from this point forward clearly learned a lot from these patterns that Rails invented. Okay, there's one thing that was actually just smooth. If we clear this out, we want to launch this. Fly, launch. It knows we already have this configured because I ran this already. I didn't write any custom configs. I didn't do anything. I just ran the command and it worked. I'll hit yes to copy the config, but we're making a new app here. It tells you I already have it, so I can just run fly deploy and deploy it. But we're going to make a new app here because I want to show you guys how easy this is. You want to tweak the settings, round as Rails, all looks cool. It uses the region closest to you based on a ping that it runs in your CLI. I want to tweak the settings? Nope. Notice here, fly Postgres. I didn't write anything to tell Fly that I needed to bind Postgres to this. It just knew it from the source. And it handles everything from environment variables to scheduled deployment and all of that for you. It just works. It's not fast. Not their fault. It's Rails setup takes a bit because it has to install all the gems. And it just, wasn't fast on that part. And to be very clear, Fly isn't serverless. These are real servers it's spinning up. It's making VPSs, running Docker in them, and installing all of our dependencies and getting that all going. That's why it takes a bit initially, because it has to get all those gem files. Once they build the cache, updates tend to be like hilariously quick because it's all there and it's just sending new code to the Docker image. You might be a little sus here that the Rails version is currently not active. This is actually one of my favorite things that they do by default with Fly. Since in serverless, when a user's not on your site, there is no server running. Having hundreds of projects isn't a big deal because as long as nobody's on them, it's not running servers. And if hundreds of people are using all of your stuff, you expect it to run accordingly. That doesn't work that well with traditional servers. If I have like 5 versions of the same project and I deploy them all, I'm spinning up 5 VPSs, and that sucks. Fly intelligently sleeps services when they're not getting traffic, and then they spin them up when you hit the request button again. So if I go to the site, it's going to be slow for a sec. I'm not going to slow it down so you guys can understand the real cost of doing these things this way. But once it finishes, now it's loaded. Now from this point forward, it flies again because the server is up. And after a certain amount of time, I don't even know, I haven't looked yet. Once a certain amount of time passes, it will sleep again. And now you're not being billed for it. Since I started all of these projects, which by the way, it's not a small number. I have a lot of projects in Fly here. I've used 33 cents of my $5 of free credit every month. So it's effort to run out of provisioning here. It's effort to rack up a big bill here. You got to have your stuff going constantly. And obviously, once you've decided this is a production workload, you can accordingly mark it as never sleep, and it won't. But at the very least, when you're deving, when you're spinning up side projects, doing all that, your bill is not going to be particularly bad. It was nice. I really feel like they found this balance where I get the benefits of traditional server hosting, but also can just one command deploy and spin up tons of these side projects with no issue. Speaking of which, here is yet another clone of this project that I just spun up. And if we hop in here, I can click the link. And now we have a running version with all the migrations run. And if I go to results, you'll see it only have the one vote I just did there. Here we are. Arkaludon with the one single vote and nobody else's votes. How cool is that? I actually thought it was really nice being able to spin up a project this easily. None of the other projects were quite this easy to spin up, so I wanted to give credit where it's due. Rails plus Fly, baller combination. Finally, I can stop talking about Rails because now we're doing the Elixir version. I'm excited for this one because if you guys didn't know this about me, I'm a huge Elixir fanboy. I've been using it for a while now. It's not my default language. It's not my language I build most of my products in anymore, but it is the language that made me feel like a really good engineer for the first time, and it is one that I miss dearly. Phoenix, however, isn't something I've spent as much time in. Elixir is a programming language created by José Valim in order to try and bring some of the niceness of Ruby into modern times with really powerful functional programming and concurrency patterns. I love the language. Phoenix is trying to do what Rails did for Ruby. So Phoenix is a web framework built on top of and around Elixir to give you all the things you would expect from a full stack web framework. I don't have anywhere near as much experience with Phoenix as I do with Elixir, and both of those experiences are quite dated. So this was a fun learning time for me. And not just me, Ben as well. If you're not familiar, Ben Davis helped out a lot with this project as well as with the channel as a whole. He wrote most of the code for the initial run on the Phoenix version of Roundest and went crazy with optimizations. But I want to show it as it is now. First off, you click and things happen pretty quickly. If I hammer the button, you'll see it's pretty dang fast. The one thing that's slow is the images of the Pokemon. Like I'll be hitting the vote and it'll still be showing the old picture still. But how is it so fast? The reason's kind of simple. It's a little thing called Live View. Live View makes a WebSocket connection to the server. So when you hit the vote button, you're not sending a post request and fetching new HTML. You just have this WebSocket connection that continues to run. If we look here at the Messages tab and I click a vote, the vote gets sent up and it says that the type of event was click, the event was a vote, value was winner, loser, pair. And in here, we have now sent this message down the WebSocket connection and we get back this response that tells us what the diff is on the page. So we have status, okay, response, diff, and the diff tells Live View's JavaScript which elements to swap and what to swap them to. So it swaps the number to be Arbok in this case. It swapped King Gambit for the other value. You get the idea. It just sends this minimal diff on what needs to change on the page and nothing else. And since it's using the existing connection, it's really fast. The pictures are slow though, so Ben and I made a turbo version where the pictures will come in even faster because we preload those ahead of time. So now when we click, you'll see the pictures change almost immediately. I'm pretty sure this ended up being the fastest version overall. It's kind of nuts how fast this runs. Like, I was genuinely blown away. Enough of that, though. We need to talk about the setup and the actual code that made all this possible. I have the code base here, immediately not quite as chaotic looking on top, but admittedly, there's a lot of code in here. To give this a fair comparison with the Rails version, I wanted to run the line of code counter again, and you'll see we have 31 files for our Elixir stuff, 47 files total, which compared 48 to 83, quite a bit fewer files, but also quite a bit more code. We only had 1,000 lines of code in the Rails version, but we had 1,395 here. If you remove the turbo optimizations we made, it goes down to 832 lines of Elixir and 1,236 total, which is less bad. Still not where I would want it, though. The amount of stuff you have to touch was higher than I would have liked, and they definitely still fall into model view controller. If we hop in here, lib, roundest, we still have controllers. We still have the actual definitions of routes and things here, and all the database stuff's in priv/repo. I still don't love this breakup. I think I get what they're going for, where lib is meant to be the library, the actual logic in the code you wrote, and then priv is supposed to be private, which in this case is data and the things that go through that library. Remember that Elixir is a really functional programming pilled community and language. So ideally, everything in lib would be stateless, and all the state would live in here. I think that's what they're going for at the separation. I could be wrong. All I know for sure is you had to hop around a decent bit between these. And if we hop into migrations here, you'll see very weirdly similar to what we were doing in Rails. The language, all fine. We define a module, which you'll see this a lot in Elixir code. You basically define modules for everything. And in here, we define these procedures. Change, in this case, will create the table Pokemon and add all of these fields to it. Nice and simple. Things get less simple when we talk about seeding, though. This ended up being a back and forth with me and Chris McCord, the creator of Phoenix, because I was surprised at how weird it was to seed properly. So by default, the seeds file from priv repo only runs in dev when you run a specific command. So if you want this to run in production when you're spinning something up, you can't really do that. So previously, I had all of the seed code written in here like you're supposed to, but in order to get this in a state where I could deploy and then run the seed in production, I had to move this to a module that could be accessed in the actual code, because things in this priv folder don't become part of the environment once you run the code. So I have to create this global setup module so I can define a run seed function in it. And then when I want to run it, I have to SSH through fly, execute the application, and tell it to evaluate this Elixir code in order to actually run the seed in production. Ugh. At the very least, since Elixir is a runtime, not just like a compiled language like something like Go, I can hook into the runtime and run commands in it, which is really handy for stuff like this. But the fact that I have to at all, that wasn't great. Also, I don't want to go too deep on this one, but environment variables ended up being obnoxious for us. We had some issues trying to get the databases set up in production because there was, I think, an outage at the time. So we defaulted to using a different database provider and setting a URL in order to connect to it via environment variables. And that ended up breaking my editor, because the editor runs the LSP inside of it when you're trying to use their VS Code extensions. It couldn't find the environment variable because I didn't have that configured in the editor. So it was breaking my editor entirely until I removed all that code. I started bringing things down to the bare minimum, like roughly where it was when we initted. Everything ended up working much better. But there was one other really annoying quirk. By default, when you set up Postgres on macOS, it doesn't have this username Postgres, password Postgres account. So I couldn't get this to connect locally to my local Postgres instance. Annoying. Once I figured that out, I was able to get working relatively easily. And since then, it's all worked really smoothly. But that was obnoxious. And I had a handful of issues. We still have this database URL call at the top that I'm pretty sure is just left over from all of that debugging. It wasn't great. You also might have noticed in the config here, we have config exs, dev exs, prod, runtime, and test. All of these script files for config. The fact that you have so many of these is, yes, annoying. That's a ton of files. But at the very least, all the config is there for you to configure. But these little things are what bloat the size of the project so much. And it's intimidating going into a project because you don't know where to start because there's just so many files. And what's generated, what isn't, what comes from the template, what doesn't, what was written, what wasn't, what is important and what's not. It's hard to navigate these code bases. And I'm saying this as someone who used a lot of Elixir code back in the day. You kind of have to learn to just turn off your brain and write the code, which is part of what I love about Elixir too. The fact that the code is as clean as it is. If we hop over to the actual Poke Live code, which is the code that powers things, you don't get formatting in these templates, which is annoying. Oh, wait, do we? Nope. Something's breaking prettier at the moment. I have it set up to auto format, but the auto format's broken with these H tags, which is annoying. I do love there's a formatter built into the language, though. Every language should have that. But the syntax here shouldn't look that bad, especially for us who are used to React, especially for us who are used to the old way of doing pre-act with the H tags. It's kind of funny seeing this H tag open string, and you're writing what looks and acts effectively just like an HTML template, but we can tag in these values that exist in the instance as it's running. I just want to show some of the fun Elixirisms here. Pipes are so cool. Effectively, what a pipe does, it takes the thing from the previous line and passes it as the first argument. So we could rewrite this code if we wanted to be this. Assign socket, comma, assign socket, comma, and then delete these. That's the same code effectively. But with pipes, you can just take a value and pass it over and over again. So you have to define tons of variables. It's a super nice pattern, and working in this code base was a huge reminder of how much I missed it. And man, I missed it. Also, little things like this, this task.start, I wrote this code so that the voting wouldn't block the user getting the next things to vote on. Since we are running this in a task, this is now effectively running asynchronously, externally, separately. So the rest of this code can run without this blocking on it. And I can define a function that's doing fn arrow, and here inline record vote, and then pass the result to io.inspect. The pipes are so nice. They're almost like bash, but so powerful. I miss pipes a lot. Something else you might have noticed if you caught me scrolling earlier is we have two render functions. How do we have two render functions? The reason that we can do this is what's called a pattern match. In this case, a pattern match on function overloading. Since we have two definitions of render, we go through them one at a time to see if the arguments we're passing match. So we're passing render an object that has keys in it. One of those keys is page, and one of the values it could be is loading. So if we pass render an object that has page loading in it, then it will hit this function first. So this is the loading state is what we get as a result. Then we have a second render function here with assigns. This one doesn't have a pattern match on it. So as long as you pass one or more arguments, this render function can be called. And now we have access to values. We know that they exist because otherwise we would have hit that loading state. If you want to see where these are assigned, that all happens in the mount. So in mount, we have the cases, in this case connected, and when connected is true, we send a random pair. When connection is false, we send page loading. The reason for that is a somewhat tragic bug. Live view double mounts, because initially it has to render the HTML, so it runs the whole page on the server side, generates the HTML, sends it, and then the WebSocket connects. To show you this bug quick, I'm going to comment this out and put it back the default, somewhat obvious way. Now if we go and run this, you'll see a very interesting thing happen. See the Pokemon change right when the page loads? That's because we're calling random. So when the page is being generated on the server, it assigns specific values to first and second, but then when the WebSocket connection happens, a new set is being sent down. In order to prevent this, you have to have an initial default state that in this case is loading, and you send that when connected is false, and then when connected is true, you send the random pair instead. So that's why we have the two render methods, because we want to render with the loading state initially, and we want to send down these values after. Didn't love that I had to do this, that the separation was done this way. No other framework does this great, but the things you can do to work around it in something like Next.js with server actions and server components are a little bit nicer. Not a lot, but we'll get there when we get there. Overall, though, good. And honestly, I was just surprised with how nice the mental model works once you get it. The last piece here that we have to go over before I can dive deeper into the mental model is how we record votes. So we have this record vote function, takes in the socket and the winner ID. We get first entry from the socket assigns first entry, second entry from the other. Winner, loser, we have this, I love the cases and the destructuring in Elixir. We have case first entry is winner ID. If that's true, then... Oh, did I get these backwards? That's hilarious if I did that and nobody noticed. Yeah, case first entry.id is the winner ID. If that is true, then this should be first entry. Thank you, cursor, for fixing that for me. Yeah. Oops. Dumb mistakes happen. But now we have first entry, second entry, winner, loser. Super simple syntax for grabbing with just the winner what the loser is. You could also have passed both. I'll show you what that looks like in a second. The important piece here is the repo.transaction. Here we have case winner, ecto-chainset.change, upvotes, winner upvotes is 1. Repo update, we do OK winner. If that works, case loser, we do the same thing. You get the idea. And we can roll back at any point if these don't go as expected. Now we have the get random pair function, and that's it. But where's the code for updating the UI? How do we actually change the UI once this has happened? Here. By assigning new values, the UI automatically changes. And this was the oh shit moment for me with live view. It has removed all the state from the client code. There is no state in this render code. We have the image tag that uses the dex ID for the Pokemon's source for the image and the alt for the name. And we have down here, we use the ID and the name to show you what you're voting for. And then the button, which has the PHX value winner ID and a PHX click vote event. So now when you click it, it's going to trigger a vote event in our socket listener. So how does the update happen? When you call socket.assigns or assign a new value to the socket, it will re-render the HTML using the new value. So if the first entry changes because you sent something down the socket, the UI will get an update on what they need to change, which is actually really, really nice because now you don't have separate logic syncing these changes between the server and the client. You just assign the updated value and the correct UI kind of comes out as a result of that. This really feels like my functional programming brain being scratched, where we have the state, which is whatever exists in the database, and the UI, which is the logical output. And when you want to change it, you update the state and the UI just updates as a result. It almost feels like React-y in that sense, where you're not writing custom update logic like you are in almost every other tool. I found this really handy. But what about that turbo version? If we go to preload PokeLive, you can see how this works. The only difference here is that we have a hidden set of image tags, which this should be in a hidden div. Ben was just working on this in a different way. Technically, and I'll even do this just to make my point, div class equals hidden. This is the correct way to do this. I wish that the formatting worked by default. That went too far. Cool. There we go. So we have these hidden images that are the next first entry and the next second entry. And since we have these as hidden elements, the images can prefetch before they get shown. And we manage this with some relatively simple changes to handle event. Also, by the way, if you want to handle different events, you just define a new handle event and you put a different string here. Vote is handled because we have handle event vote, but if we want a different event, you just define a different function. So on record vote, we grab the first entry and the second entry from the socket, and we create a new next first and second with the random pair here. And then we update, send all these new values down as I was discussing before. The one thing here that I didn't realize I hadn't changed over in the preload version is we're still blocking on record vote. So ideally I would move that up like I had in here. So task start is the way that's done. And then we have the rest of the code underneath. And I'll make that change quick because I want that. Cool. So I'll do that here instead. I think this one still expects loser ID, so we'll do it that way. And we do that. I don't know why the formatter is not working. Just make sure those changes work. Okay, yeah, that's way faster. That's actually really nice. Cool. So I just moved this to match the way I'm doing in the other file. So we don't block on the vote anymore. We just grab the updated values, which in this case, the new first entry and second entry are whatever next was prior, and we get new next values as well. We then just assign all this here, and you're good to go. Pretty handy. Overall, these things are really good. Also, way fewer things you have to hop between when you make these changes. You can put almost all the logic inside of the web live files. So I just have my preload Pokemon live file. This does basically everything other than define the data model, which is really nice to not be hopping around the code base constantly in order to make changes. That said, of the 31 Elixir files and the 47 total files, I counted, there are probably 7 files total that I would say matter in this project, like things that I actually changed and wrote meaningful logic in. It's not much. I will give credit to the router though, as verbose as it is with all of these things where they have like the pipeline that includes session, the live flash for all the live view stuff, the route layout, all those things. It's nice having it all here because you can change anything at any point. Phoenix and Elixir as a whole really lean into this idea of everything, every config, every environment value, everything is just an Elixir script that you can make changes to. It means you have way more code, but it also means something like the scope for web is very clearly defined here, where I can set different routes to do different things. To add /turbo, I just had to create live /turbo and then tell it what I want it pointed to. Very nice. I like, again, having these explicit configurations of how routing works, so you know for sure what routes are coming from where. What I don't love is that I still have to define a controller separately to get a lot of the things that I need to get. So to actually sort everything by the votes, you have to write all that in the controller. And by you, I mean, in this case, Ben, who did all of this part for me, but you get the idea. There's a lot here. Man, I love the Elixir syntax. It reads so nice. We have the query, we pass it to repo all, we pass that to enum.map. Here's the map function. And we take this Pokemon and we put total votes on it, we put win percentage on it, we put loss percentage on it. It's so nice. The syntax is beautiful. I miss it every single day. Elixir, I might come back. Since I just made those changes to speed it up, I want to deploy that quick, and I'll show you how easy that is. Fly deploy. And in just a moment, we'll be deployed. Cool. Yeah, it's released. It works as expected. If I go here and hit turbo version now, it should be even faster. Oh, yep. I'm going to hammer it as fast as I can. That's stupid. It is dumb how easy it is to spin something up like this and have it be that fast. And again, this isn't client-side logic. I'm not fetching a new pair or generating the next thing on the client side. There's a lot of ways you could hack this specific project on client. The fact that all this logic lives on the server and it still runs this fast is genuinely absurd. It's so cool. But if I just sit here talking about how cool Elixir and Phoenix are all day, then I didn't do my job, which is to show 5 stacks. So let's dive into the one I am the least excited about. Go, GraphQL, and a single page app. Here it is, deployed in all its glory. You click a vote button, and it goes. It actually goes quite fast overall. Not as fast as what we just saw. Like I'm clicking as fast as I can, and that's as fast as you can get it going. But it is still quite fast. Also, navigation flies because it all happens on the client side. You click results, and it just loads immediately. But you might have noticed a little thing here, GraphQL Explorer. This is one of the coolest things of working with a stack like this. You get an explorer where we can look at all of the different things that exist on this GraphQL endpoint. So we can go here, see that Pokemon has these different fields in it, and you can write a custom query. Query, test query, and here Pokemon, and here you put name, run, and here's all of the Pokemon's names. Super, super nice. And as a front-end dev, it's super convenient to be able to hop in here, write out the query for what things I want, get it exactly how I want it, and then go drop it right in my code base. So if we go to my home route, I have the Poke query, get random pair. Well, it's just named random pair. Random pair has Pokemon 1 with an ID and name and Pokemon 2 with an ID and name. I also have the vote mutation, which is very similar. I just pass it the upvote and the downvote, you call it, and you're good. Not what I meant to click. Cool. Super nice and simple. We'll get to some less nice and simple parts in a second, but actually using it was nice too. I used Apollo because it's what I'm familiar with. I should have mentioned this before. When I was at Twitch, we had a Go GraphQL backend and an Apollo React client frontend. Not a bad experience overall, but there were quirks, and I hit a handful of those as I was working on this. We have use query and use mutation, which, fun fact, started with Apollo, and Tanner Lindsley saw them, liked them so much that he decided everyone should have access, which is big inspiration for why React Query exists now. But this isn't React Query. This is Apollo client, and you just pass it the Poke query, or in this case, the vote for the mutation, and now you have the mutation that you can call, as well as data loading and refetch. And of course, as you guys know how I am, we have our type safety. Pokemon1, type name Pokemon, ID, number or null, name, string or null. We'll talk about the nullability in just a second too. You'll notice a lot of null or undefined options here. GraphQL be GraphQLing. I have my handle vote function, vote mutation, you pass it the values, and then very boring traditional React code. We have button on click, handle vote, and button on click, handle vote. And this refetch call fetches the new Pokemon contents when the handle vote gets called without blocking on the mutation. So again, we triggered the mutation to do the vote and the update on the client side without those blocking each other. There are catches though. The first is that turbo functionality I showed you guys before where we prefetch the next ones. Doing that with this pattern is obnoxious. And the right way to do that, so to speak, would probably be a new backend function. But I'm just working on the front end here. The backend is behind quite a wall, and we'll talk about that wall in a second. But man, getting all the parts wired properly here, hellish. I did not expect it to be as bad. And to be fair, to be very fair, it was super smooth initially. I got everything working with a functional query and a front end that showed and worked as expected in like 20 minutes. I then spent the next 4 hours getting type code gen working. It was somewhat easy to get it working, where it would read my queries and generate types. But if I do this, what all of the docs say is the right way, and I move this to a GraphQL tag template literal, here I have the GQL tag. Notice this type error. We're getting a type error because if we go to the generated GQL tag, it knows this source. It knows random pair. It puts this here when it generates, but it doesn't know how to handle a tag template literal. What's even funnier is even if I'm running the code gen, which I'll make sure is running. Cool. So now the code gen is running. We still get the correct type here. So it is calling this, and it knows what the return type is because it's using that here for Pokemon query. And if we keep scrolling down, it still knows that this should be a Pokemon. Actually, I think it breaks at that point. No, it knows results query, but it starts to break where it knows where the type is because that string breaks. So I can just wrap this in parens and it works, except if I tab this, my autocomplete breaks, my prettier breaks, because prettier doesn't know that this is GraphQL. And that's why I also have to add this GraphQL comment in order for it to know that this is GraphQL. So I hit that, I save, and it will now auto-format itself again. Ugh. So we have to use the GraphQL tag in order to make it a GraphQL query. And we have to add the GraphQL comment in order to make sure prettier behaves properly. And then we have to write all of the configuration for the code gen, which I spent hours in this file asking for help from GraphQL experts and going back and forth. I'm not convinced this can work any other way right now. And if somebody wants to show me a minimal repo with all these things fixed, awesome. I'll gladly take a look. But as far as I am concerned, this is a miserable experience. And I would not wish setting up GraphQL type gen in modern days with Apollo on my worst enemy. I got gaslit so much by the docs, by existing issues, by the comments from when I tweeted about this. It was miserable. And it took away all of the smoothness that I had experienced setting it up initially, which was really disappointing because that first 20 minutes, I was like, wow, this is why I missed GraphQL. This is why I missed Apollo. These things are really nice. And then as soon as I wanted type safety, I felt like I was bashing my head through my monitor for hours. But once you have Apollo set up properly, you get a lot of niceties. If I go to 5173, which is the Vite extension, I have this. It's still working as expected. But the dev tools, oh man, this makes me so envious as a Next.js dev that like we don't have this stuff in Next. Here I have all the queries that run on this page. And when I vote, you'll see the mutations too. I've run 4 mutations. You can see the exact things that got fired for those mutations. I see this exact query, the exact code that I wrote here, and I can even see the cache data. Here are the things that it cached. Cache the type name as well as the Pokemon. And I can explore the whole cache, but most importantly, I can explore all the things I can do. So in here, I can run or write an example query. I can make changes in it. I can then copy it and paste it into my code base. It's so good. The quality of these tools is annoying when you're not used to having them anymore because you work in things that don't have this level of developer tooling. Is it worth the hell I went through to get here? But I can see why this is something that is so demanded by front-end devs. And the results speak for themselves. It runs great. The DX, once you deal with the comments in the type gen, isn't too bad. And for an idea of how much code there is, we got 14 files of TypeScript, 20 total, and only 507 lines of code. It's not that bad, right? Well, I have to come clean. You might have caught on if you were paying enough attention, but this isn't a React implementation. This is the React GraphQL Go implementation. I have shown 0 backend code so far because this is actually one of the nice things about GraphQL. It lets you separate your front end and back end aggressively. And as long as the schema is followed on both sides, everything comes together right. So I wanted to do this justice. I wanted to simulate my experience working in these tools to the best ability I could. And the reality is that I avoided the Go side as much as possible. And that's why I'm bringing Ben in to talk about his experience doing that part for me.
Thanks, Theo. So, Golang. I actually got my start on YouTube doing Golang content. Back in like my junior year of college, I was really into the language because the concurrency model was super fun to play with and I was enjoying watching Golang videos at the time, so I spent a lot of time on it. But over time, I've kind of fallen out of love with it. I haven't really used it as much lately just because of the projects I've been building. So this is actually the first Golang project I've done in quite a while, and it was an experience. This is the project, and right off the bat, I want to get a couple things out of the way. First of all, everything is just dumped into a giant func main within the main.go. In a real-world Go project, this would definitely be split up into something more sane than a giant main file, and frankly, figuring out a good way to organize and set up Golang projects is no easy task, and I really didn't feel like dealing with that here. So we just dumped it all in a func main. So I have a couple extra files in here, like in my DB package, I have a new connection function, I have a function to set up the schema in the database, and I have a function to seed the database. This is, again, probably not how you would do things in a real-world project, but it was just useful here to make it so that I could make this setup.go script. I wanted to make it as easy as possible to just go in here and run the setup.go script to create your database table, to go through and seed it so that you can just get a really nice experience out of the box to actually play with this. So we just kind of made it work with that. So for the backend, I ended up using the GraphQL Go package. It had a lot of really nice built-in things to make setting this up a lot easier. So when you go into the main.go for the first time, you'll notice that it's very heavy on type definitions, and that's kind of a lot of what this felt like. What we were doing here is we're basically defining our Pokemon, we're defining our results, and these are the special Golang structs. I actually don't remember the name of the syntax, but this piece right here, where we can define in our Pokemon struct that when it's coming out of the database, it's going to be lowercase id. When we want to send it over to JSON, it's going to be lowercase id, and that's going to be really important in a second here. This sort of syntax to set up the structs was really nice. This was one of my favorite features of Go back in the day, and I still really is. The next thing we sort of needed to do is go through and define our Pokemon type and our result type. And these types are different from the built-in Golang types. These are actually dedicated GraphQL types from the Golang GraphQL package. So if you're not familiar with backend GraphQL, a lot of what your job is to define these types that you're going to then expose to the client and let them query. You saw earlier what Theo was able to do in his dev console, where he could go through in the Pokemon type and he could grab a list of Pokemon. He'd pick the name, the dex ID, the upvotes, the downvotes, whatever he wanted, and our job is to set that up for him. So what we did here is we created a Pokemon type, which will basically tell GraphQL that this is what a Pokemon is going to look like. It's going to have a GraphQL field that's an int, a string, and then more ints. We also have a result type because the results needed to look a little bit different. It wasn't just going to have these in here. We also wanted to calculate some more things in here to give that better experience with the percentages. So we had to return out a win percentage, a loss percentage, a total votes, and all that stuff. So we create these two GraphQL types on top of our two Golang types, and those are important for how we define the queries themselves. Down here, we're basically defining the fields for our queries. The first field we have in here is the Pokemon field, and basically the type of it is going to be a new list of Pokemon, and then the resolver function right here is basically what we need to do here is we need to provide all of the information it would need to return that down. So even if the end user only requests the ID or the name, we still need to provide all of these different things. We need to provide the name, the ID, the upvotes, the downvotes. For the database driver, I'm actually using SQL-X instead of SQL-C. It's basically just a very light extension on top of SQL-C, which basically what it allows us to do is pass in a reference to our Pokemon slice, and then it will just automatically dump everything in there. We still have to hit our classic if error not equal nil, but then we just return out our Pokemon and it'll work. And one of the things that was incredibly nice when working on this backend is developer experience is not just better for the front end, it's actually kind of better for the back end because we also get this nice GraphQL Studio. So I can go through here and I can test out my Pokemon query here. I want to grab my name, my ID, my upvotes, and my downvotes, and then I can run it and I can test out my results right here. This is a really nice experience when doing dedicated backend development. I'm working on another project right now, which is a dedicated backend in Hono and JavaScript, and we're just using REST for that. And we have like Swagger API documentation so we can get some kind of feedback and some visual thing here. But again, most of our testing is just kind of happening within Postman without type safety, without anything like that. But this, we just have this really nice little playground to do stuff. Now, obviously, if you added in authentication or more complex things there, you could add a bit more friction, but it's still very easy to work around that. And it's a really nice way to develop backends. Now, outside of that Pokemon field, we also have the results field here, which is a very similar process. It's just a little more involved since we have to calculate out win percentages and loss percentages. So we just do some basic math in here to calculate those out. Then we have this random pair field. And this is actually kind of one of the interesting parts about working with a dedicated GraphQL backend, especially when you would have a heavy front end and back end team split. It was funny, Theo actually sent me this message where he was asking me when we were in the middle of building this, like trying to decide if I want to make you do a server-side get pair query or if I should just eat it client-side. Tough call, which is very much the GraphQL way. And in this case, since it was a pretty small problem and I was already working on some front ends for it and I knew exactly what he needed, I actually went ahead and made this random pair before he even asked me to, and it kind of ended up working out nicely. But in a lot of cases, that won't end up happening. You'll get very generic like Pokemon endpoints where you would kind of just grab all the Pokemon, sort through them client side, and then do things there. Obviously, that's kind of like a team sync issue, and you should create better APIs for that, but I think oftentimes in the real world, it sort of just pans out that way. And another example of this is actually in the mutations. We'll talk about this next, where obviously within this app, you need to allow the user to vote on which Pokemon they think is the roundest. We had to create a new mutation here, so again, very similar, we're creating a new GraphQL fields. We're gonna go ahead and define a vote field here, which is going to have a return type of a vote result, and that vote result is just going to be a success boolean. But if we wanted to optimize this a little bit more so that he didn't have to refetch on the front end, I think you mentioned this earlier, what we could have done here is we could have gone through and actually returned the next pair here. So the success on the vote could have been returning the next pair. And that's the kind of optimization that is subtle and you probably wouldn't think of when you're just building a giant API like this. But when you're working in a full unified environment, like a Next.js type thing, or even like a Phoenix or Rails type thing, you can go through and make these more granular adjustments because there's no wall between the front end and back end team. But outside of that, for the actual mutation syntax, it's honestly really not that bad. We have our arguments here where we need to pass in an upvote ID, which is going to be an integer, a downvote ID, which is going to be an integer. And then for our actual function here, it's just some simple SQL. We're grabbing out our arguments, opening up a database transaction, updating the two Pokemon, and then returning a success equals true. Nothing too crazy there. Then finally down here, we need to hook everything up and return it out to the user. So we're going to go ahead and create our root query, which is just going to pass in the fields. Then we're going to go ahead and define our schema, which is going to have our query be the root query. And then our mutation is going to have just, we're going to call it mutation, and we'll pass in our mutations from above. We go down here and we formalize our schema, make sure that everything worked correctly. If it didn't, we just log fatal F. We create our server handler. We go ahead and set up cores so that he can call this from a client-side React app, and then we start our server. And that's it. And it's really not too bad. The overall experience of developing this was pretty painless. Golang really is pretty simple and easy to use. And honestly, having the nice GraphQL studio here to go through and test everything as I'm building it was a really nice kind of flow. And then the deployment experience from Fly was just painless. I literally just ran Fly launch in my terminal, and then it figured out exactly what it needed. It knew it was a Golang project, set everything up, and it was live. Super, super easy. This is definitely a nice way to build dedicated backends. Overall, I'm pretty happy with this project. I have my problems with Go, but that's not for here. If you want to listen to me rant about Golang for 10 minutes, I'm going to put out a video on my channel at the same time as this one, going over my thoughts there. So with that all said, back to Theo.
So when you consider the fact that both backend and front end had to suffer a good bit to get this set up, it might not seem worth it at all, but it is. It's not worth it on solo projects or on teams that are very deeply integrated. But once you have a big enough company with many different teams working on many different things, having a standardized API with a spec that is honored on all sides has a ton of benefits, especially once you start implementing on other platforms like mobile. But as great as the Apollo dev tools are, it is not a good experience, and we're moving off of it as an industry for a reason. I would avoid that part, and I'm so sorry about the code gen thing. It is hell. And you're going to have to set it up to have a good experience, and it is hell. But once you get all these things together, good overall. I see why I liked this. I understand why the GraphQL revolution happened and everybody was obsessed with it, because this does seem like it's the obvious future. It's just a hell of a thing to spin up. And just to do a more fair comparison, when you run clock with the backend and front end code, you end up with 952 total lines, 14 TypeScript files, 5 Go files, almost even split between the code on the two of them. Still less than both the Rails version and the Elixir version, but that's a lot to have the same amount of code on backend and front end like that. Yeah, it is what it is. And now for the version that will probably be the most familiar to y'all, the OG T3 stack. Quick history. My first actual video on my channel was Roundest. This page isn't going to load because the free tier database is dead, RIP Planet Scale free tier. But Roundest was the first ever example of a T3 stack application. I filmed it live on stream, posted it on YouTube, didn't expect anyone to watch it. It got like 300,000 plus plays. It was the start of the T3 stack, in a lot of ways, the start of my channel. So I owe this project a ton, but I also haven't revisited this way of building directly in a while. So I restarted from scratch, this time using Create T3 app, which has since been created to make T3 apps faster, but I didn't use all the new things. I intentionally used pretty much the exact same stack I used when I first set up T3 stack and made the original Roundest version. That means performance is fine, but you'll see the first vote took a second because it had to spin up that cold start. Now it's going, and if I hammer it, it just spams that one vote. Not the fastest thing in the world. It is what it is. But the DX aged surprisingly well. Let's dive into the code. As I said before, I started this just running pnpm create T3 app, specifically chose Pages router. So this isn't using any of the new app router stuff. Everything's in Pages. I have my index, which is the home page. I have results, all the things you would expect. I went heavy on Prisma and TRPC for this, though. So here we have the mutation and the data for the pair. We have api.pokemon.getPair.useQuery. Somewhat similar to what we were doing in the GraphQL version. However, what you can do that's very different is you can command click get pair. And here is the backend code. We have source/server API routers, and here is one of our TRPC routers. This one has get pair, which is a public procedure, query. We get 2 random numbers up to 1025, and we grab those 2 Pokemon from database, and then we return those. Super, super simple. And all of the type safety comes from inference. So since we return Pokemon, I had to put this as const so it knows that it's an array with 2 Pokemon instead of an array of n Pokemon. You know that because if I hover here, we scroll to, actually here, you'll see here output read only ID number, comma ID number. If I get rid of this as const, it ends up being ID number array, we want it to be a pair. So I put the as const, which tells TypeScript, hey, this is actually constant. It's just these two values. And now when we go here, we'll see Pokemon 1, Pokemon 2. I don't even think I need this anymore because I put all the assertions there. Yeah, cool. We know Pokemon 1 and 2 have to exist because otherwise data wouldn't exist. I didn't even talk about the null stuff on GraphQL. Don't just put this in there. The amount of crap I had to do to handle nullability in GraphQL, because by default, everything is nullable. The amount of exclamation points in this code base is horrifying because I had to. Even if you assert relatively deep in, everything still could be null or undefined. So I asserted that data random pair exists. I assert that Pokemon 1 and 2 exist. I throw if they don't. That's why that code was left over. And now we know that this has to exist, but all the individual fields also can be null. Because with GraphQL, everything's forwards and backwards compatible. So if you query for a field that doesn't exist, it just gives you undefined, which means everything by default is treated as undefined, which sucks for your type safety. With TRPC, everything lives in the same TypeScript code base with the same TypeScript server. So you can not only not worry about these nullability things, you can just command click between stuff and it works. It's super, super nice. So none of that, no weird exclamation points everywhere, no weird assertions. It just does what we're supposed to. This handle vote code is basically identical to what we had in the GraphQL version. We're just calling the vote mutation and refetch. We should probably talk about the ORM though, because that's an important piece. I bind it in here. This is all, again, code that comes with the Create T3 app template. But if we hop into Prisma here, you'll see the schema.prisma file. This is our actual schema. This is the source of truth for our database. Everything else, our migrations, our data dates, the types in our code base, that all comes from this Prisma file. And it has to generate both of those. You have to run a Prisma generate command to get the right types so you have them in your code, as well as to get the migrations and whatnot so your database is synchronized as well. It's overall not bad to work in. I did miss the syntax of the Prisma files. It's fine. We have the model for Pokemon, name, string, vote for, and vote against. The Elixir version and I believe the Go versions just keep track of votes as tallies on the Pokemon object. The other ones that I wrote the backends for all have vote as its own model, which is a lot heavier, but also makes race conditions significantly less likely. So this is a more complex relation, but it all behaves as expected. I like their little relation syntax. It even gives you errors if things don't exist. They have a VS Code extension for Prisma files. Pretty cool. All worked for the most part. There was a catch though. Seeding. They don't provide any real recommendations on seeding stuff properly, so you have to do that yourself. So I made a scripts file, seed.ts. This again calls the GraphQL query for the official, unofficial Poke API open source project to get the actual data and use it and then insert it in the database. The problem is you don't have a way to run this. Prisma has no concept of a seed execution, so in order to run this, you have to create your own db seed command. I tried using tsnode for this originally. I'm pretty confident in saying at this point that tsnode does not fucking work. I lost a lot of time to that, gave up, switched to tsx, which is TypeScript execute. Then it finally behaved. Then I could seed. Again, no seeding in production, but thankfully, since I was already spinning up a different database and connecting to that via an environment variable, that was relatively easy to fix by just running the seed locally. Not the most secure way of setting things up, but at least it worked. My biggest takeaway from working on this one, though, had nothing to do with any of those tools. It was cool that TRPC still is so nice to work with. It was cool that the Prisma syntax still holds up and was a good experience overall. It was cool that deploying was just Vercel deploy or going to GitHub and clicking the button. What wasn't cool was the layouts, because I wanted to have on all of the pages, which there are only two of, I wanted to make sure the top nav was identical on my different routes. I'm going to go back to the GraphQL version because I didn't touch on the routing enough, and it was actually quite good. If we go to the router TSX file here, I have this browser router. This comes from React Router. And in here, I have path /. It has the root element. It has two children. One is also on path root, which means this is what you get when you go to the homepage. And one is on path /results. But both of them have this root, which means whatever I do in here, importantly, gets put into this outlet. Outlet also comes from React Router. And since I have outlet here, whenever I have this as a parent in the router and then children, those will get passed in as that child element. So having a vote page and a results page sharing the same top level nav is trivial. And we also have this one place that is the source of truth for how all of our routes work. I miss configuration-based routing. Honestly, it's a bit of a wake-up call for me on how much I missed it. This part was really nice. And as much as I love configuring all of these parts, like setting up the entry, binding this in the HTML file properly, wrapping it with the Apollo provider, building a router, setting up the routes and all of that. Like, not everyone should spend their time doing this. I've done it so much in the past that it was fun for me. But with Next.js, you don't have to do any of that. There is no route file. There is no root file. There is no concept of configuring your routes that way. There are just the things you put in pages. If you want a new page, you just make a new thing in the pages folder. But how do you share layouts? A lot of steps. And I have been so spoiled by AppRouter making this easy for me. So step 1, votepage.getLayout equals getLayout. GetLayout is a function I defined in utils layout. So if we hop here, we'll see I have the root layout function, and then down here, export default function getLayout. Note that this doesn't take a React element as a child. It's not a component. It takes it as the only prop. So you can't just have a root layout component. You have to make a custom getLayout function that calls your JSX things and passes it the right way, because it will not pass it the right way. But that's not even the worst part. The worst part is, despite being recommended in all of the documentation for Pages Router, this doesn't do anything by default. You have to create an underscore app TSX, or use one if it already exists. Then you have to define this get layout in here by grabbing it off of, not page props, off of component, because that's where we assigned it here. So the page component has this get layout function. We call that, and if it exists, we call it with page. Otherwise, we create this inline function that just returns this itself. And then we call getLayout, either the real function or the stub one we made, and pass it the page component with the page props. Holy shit. And this doesn't even work for nesting, by the way. If you have a layout and then another layout inside of it, this just doesn't work at all. This sucked. This sucked hard. This sucks so hard that I would not blame anybody who used Next during the Pages router, had a layout thing that they had to do, and concluded that Next sucked and just never touched it again. I would understand. I knew this was bad. I had forgotten the level of bad that it was. Enough so that I would not recommend Pages router at all anymore, even if you use AppRouter in a boring, pagey way where everything's on the client side and you just have use clients on everything. That is still better than the hell I went through for that. I would not wish that on my worst enemy. Before I forget, here's the lines of code for the full stack T3 version. It's 600 lines of code total, 13 TypeScript files, 22 total files, 450 lines of TypeScript. That's not bad at all. It's good bit less than every other version, but remember, this has the backend and the front end. So that's really nice. It turns out combining your backend and front end makes your logic so much simpler that even with all the boilerplate from Create T3 app, you end up with way less code, which is sure not that important a metric, but it does show how much easier to build and maintain this can be. And less code will almost always be more maintainable when it gets to this level of difference. When it's half as much code, that's half as much surface area that a bug could exist in. And I have to bring it up again. The performance, especially with those cold starts, not great. Like I clicked vote and then I had to wait like 2 to 3 seconds there. I'm clicking now. I'm clicking now. I'm clicking now. It sucks. The performance is slow for a handful of reasons. The biggest one is that nothing happens on the client until the server is spun up, the database is connected, and then the result is sent. And that whole process just takes a lot of time. And yeah, the result is what you saw here. It's slow. We're not doing any caching. We're not doing any optimization at all. It is what it is. T3 Stack was a huge level up in the developer experience of building in Next.js, but it was still not the levels of performance that I seek and that others seek. And the DX had issues, especially the layout stuff that I just showed. And that's why we're going to close out with the server component version. Roundest RSC edition. I knew this was going to be good. I knew this was going to be fast. I'm still amazed. I'm clicking now. I'm clicking now. I'm clicking as fast as I can. It's not as fast as the Elixir version here, at least, but it still flies. Without the network tab, you'll see something really important. Only one request is made. The post request sends back the data to update the page. That's a single flight mutation. None of the other solutions do this. Every other solution requires multiple back and forths or a WebSocket to do the back and forth. This version is one click, you get the new data. Really, really nice. And where it gets even cooler is when we go to the turbo version. And then I hammer the button. It's going, I think it's actually slightly faster than the Elixir version. So we have a layout, which, by the way, actual stacking layouts with the routing. I don't want to go deep on how React server components and Next.js app router work here. Hopefully you've seen any of my many videos about app router and server components that cover those details. What is important here is the main page. Here we have vote content. 2 Pokemon equals await, get 2 random Pokemon. And then we have the actual code. We have class names, flex, justify center, 2 Pokemon dot map. And we have the 2 Pokemon. This is the divs for the little parts that you vote on. This is that guy and that guy. And here we have the button, which is inside of a form. This has a use server, which means this is a server function that the client can now call. Const loser equals 2 Pokemon, and we grab whichever one isn't the one that we clicked on here. It isn't the one that's this Pokemon's ID. Then we record the battle, Pokemon.dex number, loser.dex number, and then we revalidate path /. That's it. That's the whole file. We have a suspense here, so you get the loading state when the page first loads. That's the whole thing. I'm not hiding shit here. That's it. It's actually the simplest version. And this file, by the way, isn't a client-side file. This can't run on client because it's an async component that's doing database stuff. If I put a use client on top, it just fails. And that's why the form action here is actually really cool, because we're defining a function on the server that is effectively an endpoint that will revalidate the page when the user has finished running this action. So when I click the vote, a new page comes down as part of that because we called the revalidate path. Super nice. It's actually unbelievable how simple it is to do that. So what about all the logic? Where am I hiding that? We can take a look. Let's look at the get 2 random Pokemon quick. Hop over here. The one weird thing I had to do is add this await connection call. This is to let the new dynamic IO Next.js stuff that I turned on because I wanted to try the new Canary things. This is to let it know, hey, this function's dynamic. Don't cache this. Don't put this in the static render. Don't use this for anything static. This function is dynamic, which is important because get all Pokemon is cached to all hell and back. I wrote a custom cache life to keep this lasting forever. You can even see when I hover here, 99999999. This is going to stay cached for a very, very long time. And I wanted that because the get all Pokemon call just gets all the Pokemon from Poke API. I don't need to hit this every time somebody loads a page, does a vote, or does anything else. I just want the results. So I grab the results, I format them how I want, I then return them. I don't have to put this in database. I don't have to mirror this somewhere else. I don't have to fetch on every request. I don't have to put in a KV. I just get all Pokemon. And since this is use cache, I can just call get all Pokemon anywhere, and it's fine. So nice to not have to add all these additional layers to store the Pokemon in my database and run a seed. This is the only version with no seed because it doesn't need one. And to actually get 2 randoms, we just take all of the Pokemon, we shuffle it, and we grab 2. So no more weird ID selections and all the weird logic to make sure you don't match the same Pokemon twice. Just grab the whole list and fetch 2. Super nice and simple. I was blown away with how much easier it is to write this type of code when you have powerful cache primitives baked into the framework and baked into the stack. I should show the vote real quick because it's important to know how the vote code works. I just used Vercel's KV here, which is a wrapper on top of Upstash, and just push a battle with a winner and a loser every time you hit vote. And we increment the wins and losses counters at the same time. So now we can grab those wins and losses for each Pokemon and use that to get the results. And if we wanted, we could put a use cache on get rankings so that this doesn't have to be hit every time somebody goes to the page. I put that cache somewhere else though. I'll show you that in a second. But it's pretty easy. Again, no real data model. There's no schema to look at because I'm just throwing this in KV because this part fits better in a KV than a traditional data model once you don't need a database for the actual Pokemon. But I haven't even shown my favorite part. I want to be clear with this next section. None of what I'm about to show is necessary, but it is fun. This is the over-optimized version, that turbo version I showed at the beginning there. How does that get so optimized? There's two fun little things I do here. The first thing is I store the current Pokemon you're looking at as a cookie, which means if I go back here and I refresh the page, it's always going to be the same pair because those are coming from a cookie. And when the page renders, we grab them from the cookie. If it exists, then we parse it with JSON. If the cookie doesn't exist, then we just create a new toRandom Pokemon value that we call from our database. Not really database of cache. You know how I'm getting it. But then we also define next pair here. Await get toRandom Pokemon. We do the same thing I mentioned before where we have the hidden div and we render the next Pokemon so that we can get their sprites early. The only other change now is in here, in the form action. Const jar equals await cookies, jar.set current pair, json.stringify next pair. That's it. And since we updated the cookies during this request, it knows to refresh the page, not like traditional refresh where the client reloads it, but specifically to send down the updated data. And since we already had next pair in the previous page load, and we had it here as well, the cookie is being updated to a value that we've already pre-rendered. Note that next pair isn't a cookie. This value doesn't exist as far as the client is concerned. It's being embedded because it's part of the vote content function. So when we write an action in here, I don't have to pass next Pokemon. I don't have to pass anything to the action. It all exists in scope. And Next and React handle that scoping for you. The way it actually works under the hood is a little more complex. You don't have to know about any of these details because they don't matter. But if we go into the form, you'll see in here, we have these hidden inputs. These are what include that additional data that isn't manually put in. Technically, you could recreate all of this and all the other solutions by writing a custom form with custom hidden elements that represent all of these things, but you have to build your own custom encryption in order to keep them safe if you want to. Versus in here, you just call them and the scoping all handles it. One other thing I need to call out is this revalidate path that I commented out. I asked for more info. I actually got more info, and it turns out I'm a little bit ahead of the curve here. It turns out that if you call revalidate path, it doesn't just revalidate the current path. It also revalidates any caches that this page needs. So if we put revalidate path here, it has to refetch all the Pokemon from the GraphQL API still. And that's slow as hell. So if we just update cookies, it will rerun the page gen, but it won't invalidate all the caches the page relies on. This is a weird niche behavior that isn't even documented. Cookies causing a router refresh is documented, but the difference between that and revalidate path isn't. And I'd go as far as to say if you're using caching heavily, you should just use a custom cookies function to revalidate without nuking all the caches to get a much better performing experience for your users. But man, this is as close to the Elixir version as you can get, if not slightly surpassing it, but without anywhere near as much client-side JavaScript and without as much complexity with all of the parts being wired together. I was blown away. I knew this would be good. I did not expect it to be as phenomenal as it is. It runs great. Its DX is the best of any of the options. And this wouldn't be fair if I didn't quickly run the line of code counter on it. 460 lines of code, which makes it the smallest version. Except I have two versions in here because I have the turbo version and I have an unnecessary route here for the sprite where I reserve the sprite on my endpoints because I want it to be cached better. I can just delete both of these quick, rerun this. 367 lines of code across 12 files. Holy hell. I hope this helps emphasize why I'm so impressed. Could you make any of these more or less lines? Sure. Could you make any of these things faster or slower with hacks? Sure. But what blew me away with RSCs is that by default, it was the simplest solution, and with not much work, it could also become the fastest. And the result is that everything was really easy to write, read, understand, and work around. I'm obviously biased because I've been writing apps a lot more often recently. But man, the power and the composability of these patterns is just, it's unreal. I was blown away. I didn't even go in depth on things like the suspense and the partial pre-rendering and the page caching because I didn't need to. It works, and it works great. I did cache the results page, though. I can show that real quick. Yeah. On the results page, I threw a use cache here because you can also use cache on a component. And now when you go to the results page, it can hit that cache and you get it super, super quick. Now when I refresh, it loads instantaneously without even having the loading state. And I can even Command-Shift-R, and the loading state's not being shown because it doesn't need to be, because it has that page entity cached. Yeah. I had a lot of fun with this version, if you couldn't tell. I kept being surprised, and I'm not the only one who felt this way. When I showed this to Ben, who's more a Svelte guy, as well as the Elixir guy who helped with all of that stuff, melted his brain as well. This stuff's so cool. I just spent the last 2 hours recording this video. This has been so much work in the making, months of planning and weeks of work to build all these projects. I hope I achieved my goal here of showing these stacks and their strengths and weaknesses and what it's like revisiting them after my long decade-plus career. I'm happy with where we landed, but there's a lot to learn from every step along the way. I hope you guys learned something too. One last thank you to Fly for sponsoring and Vercel for helping us get this whole video done. And until next time, peace nerds.